You know that BPA-free label you see on your water bottle? Ever wonder if it actually means it's safe? For years, we've been stuck in this frustrating game of chemical whack-a-mole. We ban one harmful substance only to replace it with another that's pretty much just as bad. But what if we could just stop playing that game altogether? What if we could design a material to be perfectly safe before a single molecule of it was ever even made? Well, guess what? A new scientific approach is doing exactly that.
Yeah, you've seen this label on everything. It's supposed to make us feel good about our choices. But the truth is, it's often just a sign that the whack-a-mole game is in full swing. The chemicals that often replace BPA, things like bisphenol S or F, well, turns out they can have very similar, very harmful effects. So what are we really accomplishing?
And this is the absolute core of the problem. Just swapping one chemical for its nearly identical cousin isn't a real solution. It's just kicking the can down the road. The real breakthrough, the real game changer, comes from flipping our entire approach on its head, from reacting to problems to proactively designing them out from the very beginning.
Okay, so to get why this is such a big deal, we have to talk about the main villain here, BPA. It's what's known as an endocrine disruptor. Put simply, its molecular shape is a sneaky little copy of the hormone estrogen. It can trick our bodies, get into our hormonal systems, and just mess things up. It's been linked to all sorts of health issues, which is exactly why finding a truly safe alternative is so important.
So how do we finally break this cycle? Well, scientists are now using a totally new playbook called Safe and Sustainable by Design, and it's revolutionary. It's a way to create materials where safety isn't an afterthought or a bonus feature. It's baked in from step one.
This four-step workflow is basically the hero of our story. It all starts in the virtual world with something called virtual toxicology. You use powerful computer models to check if thousands of potential molecules are safe before they're even real. Next up is green synthesis, figuring out how to make the best, safest candidates from renewable stuff. Then it's time to head to the lab for validation to prove the computer's predictions were right. And finally, polymer creation. You build the actual plastic and test it to see if it's not just safe, but also strong and useful.
This first step, honestly, is where the real magic happens. Instead of a chemist spending months or even years in a lab making and testing one potentially toxic chemical after another, you can do almost all of that initial heavy lifting right on a computer.
And we're not talking about just testing a few ideas. In this one study, researchers threw a library of 172 different potential BPA replacements into their computer model. Trying to do that in a real-world lab would be unbelievably slow, expensive, and would create a ton of waste.
So what was the computer actually looking for? It's kind of like checking if a key fits in a lock. The lock is our body's estrogen receptor. The computer was looking for two problems: agonists, which are like the wrong key that still manages to turn the lock and set things off. That's bad. And antagonists, which are like a key that breaks off inside the lock, jamming it up so the real key can't work. Also very bad. The goal was simple. Find a key that's a completely different shape, one that can't even fit in the keyhole. Zero interaction.
And boom, here's the power of this whole approach in one number. Out of those 172 initial ideas, the computer model filtered them all the way down to the 20 most promising candidates, the ones predicted to be totally harmless. I mean, think about that. It saved them from even having to create over 150 potentially dangerous chemicals.
Okay, so with the top 20 virtual candidates identified, it was time to move from the computer screen into the chemistry lab. The next steps were to figure out a sustainable way to make them, and then to put the computer's predictions to the ultimate test.
And this is another beautiful part of the story. These new molecules weren't made from fossil fuels. They were built using blocks from lignin. You know, the natural, complex stuff that makes wood strong and rigid. So the final material isn't just designed to be safe, it's also bio-based and sustainable. It's a total win-win.
So, did the computer get it right? Oh yeah, the results from the lab were just stunning. The tests confirmed the predictions with incredible accuracy. You can see it right here. While BPA shows really high hormonal activity, almost all of the new candidates showed, well, basically none. The virtual screening worked.
In fact, it worked so well that 3 of the finalists were absolute rock stars. They showed zero hormonal activity at any concentration, no matter how they tested them. The researchers then picked the one that was the easiest and most efficient to produce and got ready for the final step.
So here we are. We have our champion molecule. It was predicted to be safe, it's been proven to be safe, and it's made from renewable stuff. But the million-dollar question is still on the table. Can you actually make a good, high-performance plastic out of it?
So the team took their winning molecule and used it to build a brand new polyester. And to make it a true fair test, they also created the exact same kind of polyester, but this time using BPA. This set the stage for a direct head-to-head showdown.
And this is where things get really, really cool. The safe version wasn't just a weak substitute. It was actually better. The new non-toxic plastic was way more flexible and a lot less brittle. It could stretch to more than double its original length before it broke, while the BPA version was stiff and snapped pretty easily.
It also crushed it in another key area: heat resistance. A lot of common bioplastics, like PLA, start to break down when things get hot, which really limits what you can use them for. But this new stuff, it was rock solid up to around 370 degrees Celsius, which makes it way more durable and versatile for manufacturing.
When you step back, you realize this is about so much more than just one new type of plastic. This is a glimpse into a fundamental shift in how we create the very materials that build our modern world.
So, what's the big takeaway from all this? Well, it's pretty huge. It means we have a clear blueprint to design safety in from day one. It means we can use computers to slash waste and dramatically reduce the need for animal testing. It proves that we can use renewable resources, literally from trees, to create materials that aren't just safer, but sometimes even better. But maybe the most powerful thing is this. It shows we don't have to make that old trade-off between safety and performance anymore. We can actually have both.
This research just leaves us with this powerful vision of what could be, doesn't it? A future where we might not have to wonder if our food containers or our kids' toys are safe. A future built not on playing an endless game of chemical whack-a-mole, but on intelligently designing a safer, better world, right from the molecule up.